Hello again. I'm making a series of tutorials about the framework Chromia, and this is part 9. Currently, I'm making a lobby for the game. In part 6, we wrote the code to match 2 players, and now it's time to actually create the game entity. Let's step through the sequence of events. When Pelle wants to play, he will first look in the lobby. He cannot match with anyone, so null is returned. Pelle now enters the lobby himself. Pelle's client will keep calling the enter lobby to prove that he is still around. Now Anna appears and looks into the lobby. She matches with Pelle and gets his pub key. The next logical step for us is to create a new game between Anna and Pelle, and then delete Pelle from the lobby. We have a create game operation that Cursor wrote in episode 1. I want to clean up a bit, breaking out the meat of the operation into a function. I'm doing this refactoring since I want to be able to create the game from another operation later. Say that we found a suitable opponent via the consume lobby entry query from last episode. The client will immediately call this new create game operation, sending the opponent's pub key and the game type. Again, I use cursor chat to describe what this operation should do, namely to extract the current player from the transaction signature and randomize who should play white based on a timestamp. Random doesn't really exist in the blockchain world. We need every operation to give the exact same result, no matter when or where it's executed. That's why I want to use the block timestamp as a seed for randomness. The resulting implementation is using a tuple to pass around white and black player. Let's take a look at the tuple syntax from the docs. Rell is using plain parentheses, so you probably recognize this syntax. The tuple is returned from an if expression, and Rell doesn't use curly brackets for that, so I'm removing it. Let's break out the white-black randomness in a separate function, perhaps easier to read. Cursor forgot to verify that the lobby entry of the opponent really exists. This is important, since even though the client will send this transaction directly after an opponent was found via the query, there is still a delay before the next block is built and the transactions are executed. Depending on the order inside the block, some other player might steal our opponent if their transaction comes before ours in the sequence. After the game has been created, there is no point keeping either of the players in the lobby. We use delete to remove them. In the docs we see that delete works just like select and update. We have to use the @ with the cardinality operator. In our case we use @*, where we can delete any number of entities. Are we really deleting from the blockchain? Of course not. That would destroy its purpose. The transactions remain forever, but you can think of the entity as a filter to see the most interesting data. Okay, so you are somewhat of an SQL expert, and you are worried about this operation. Isn't it possible that, even though we check that the lobby entry do exist, someone else might still run this operation in parallel and be able to create another game right before we delete the lobby entry? The answer is no. From when an operation starts until it ends, you never have to worry about concurrency problems. Let's take a look at block execution. Say that we have 3 transactions in block 17. First, Anna wants to play Pelle in a 5 minutes game. Then Nils wants to play Kalle in a 10 minutes game. Last, I want to play Pelle. When this block is executed, this will happen. First, Anna's transaction executes. It creates a game between Pelle and Anna, and in the end it will remove Pelle completely from the lobby. When it's my turn, the transaction will fail since it cannot find Pelle in the lobby. My transaction will be removed from the block. In Chromia, transactions are atomic, meaning that they are either all in or all out. It also means that nothing else can influence the transaction while it's running. Transactions run in sequence, not in parallel. To simplify the testing, I do like last time. I create an alternative entry point to this operation so that we can send the short name instead of the long pub key. Similar setup as last time, with Pelle, Kalle and Anna in the lobby. Now Anna sends a transaction where she creates a game with Pelle. As expected, only Kalle is left in the lobby and the game got created. Now when I try to create a game with Pelle, I get an error. Seems to be working. And that's it. See you in episode 10.